Welcome friends, this is yet another video. Today we will be discussing Java again. It is a very interesting session. We will be actually covering a lot of aspects from start data types, loops and condition statements like that. We will be going forward up to files. Then we go to the next one, that is the UI, generics, polymorph, the object oriented concepts. We'll be covering almost all the aspects of Java, threading like that, everything. Generics, threading, lambda, everything in this one short session. So let's start this because we have to cover it in about 30 minutes. I don't know because it is a very large topic. We have to go fast and do the thing. So please, those who haven't subscribed, please subscribe. We are coming with a lot of informative videos, technical videos, and let's start. Yeah, so starting actually about Java. Java was actually founded in 1996 and by James Gosling. Most of the people know that. And the platform is actually write once and run anywhere. Once it is compiled to the class object, that is Java is a bytecode. Bytecodes are in the extension of class files. So we call it as class. And you can run it anywhere independent of the programming language and platform. When you can run, you compile it in Windows, then you run in Linux or Mac, wherever you want, depending on the availability of the JVM. Okay, so to install you have to go to Oracle and download, because Java was earlier part of Sun, now it is part of Oracle. So you have to go to JDK. If you want to get JDK, either go to Open JDK or go to Sun and download JDK and install it. And similarly, we are using VS Code here. That is the UI we are using. So you have to download VS Code as well as all the extensions for the Java. These are the things, requirements. You please do that because it is most of the people know how to find their way around. I am not going to go into that deeply. There's different types of data types available. There is byte, boolean. Boolean means byte is actually 8-bit information. Boolean is true or false, that is 1-bit information. Short, integer, long, float, double, character, string, and any class that you create is a data type. Any interface you create is a data type. Any record you create is a data type. So you can use all these things. Strings and integer. You have given integer here, integer value in here. Actually I assigned the value 10. Normally earlier we only int can be assigned in 10 values. Now auto unboxing is there, which provides what? Integer value conversions to objects. So there is again going to the operators and expressions. Lot of mathematical operators are there. You see plus, minus, multiplication, division, percentage. Again division is percentage is again the mode operator. That is, if there is a remainder, that is 12 divided by 10 is actually there is a 2 remainder, right? That remainder is the answer. Again increment and assign operators, plus everything like that. Increment and assign, subtract and assign. This means that when you have a value in A, that is if you have 5 in A, that means A plus 5 equal to 10, like that. B minus 5, you have B value in B value 10, B minus 5 equal to, B minus 5 means B will have the value of 5 only once it is subtracted. C star equal to 5, that means if you have value of 10, it gives value, C will have value of 10. That is operate, assign and whatever the value. No, actually it is A equal to A plus B, A plus 10, A plus 5, A plus B plus 5, B minus 5, C minus 5, C equal to C minus 5, C into 5, like that. D divided by 5, that is if we have a value of 50 in D, D divided by equal to 5 means it is 10. It's actually assigned to D only. Again the mode operator, as I told you earlier, if you have E equal to 12 and mode of E is actually 2, that will be assigned. That is increment operator a plus plus, a minus, c, a plus plus, c minus minus, like that, means it increments by 1, a plus equal to 1, that is the meaning, or a equal to a plus 1, that is the value assigned, c equal to c minus 1, that is the value assigned. So similarly, this is actually increment, that is, you have, I mean, okay, there is two operators, a plus plus and plus plus a. That is, one is, first, if you are assigning to some value, increment and assign, that is plus plus means, a plus plus a means increment and assign. That is, a plus plus means assign and increment, that is the difference. Then it is a comparison operators, that is less than, minus, less than, greater than, equal to, not equal to, all these available. When x equal to 10 and y equal to 20, x less than 10, y means x is actually true, right? Similarly, y is greater than x, that is also true. That is because y is 20, y is greater than 20, x greater than 20 is, y is greater than x, that is 10, that is true. X equal to x, that is also true, because any number, any value compared to itself is true. X not equal to y, that is also true, because x is 10 and y is 20, which is not equal to true. That is how it is comparison operator. These are all, you will go more deeply what is if and how to do that. It's actually having, if you look closely, you can see that if block is having a comparison operator is a open parenthesis, close parenthesis, open brace, close brace. This is the structure of an if okay. Now not equal to is exclamation equal to is called not equal to, double equal to is called equal to. You can even have a less than equal to or greater than equal to, and not equal to is always equal to, exclamation equal to. We can have multiple, you can actually combine multiple operators, x equal to x and y equal to y. These are all always true, right? And similarly, x equal to x, this is the AND operator. Both the conditions should be true so that this is printed. That is x, this condition, that is first condition, that is x equal to x and y equal to y is true, so this will be printed. X equal to x and y equal to, or y equal to y, that is either one of them should be true, either one of them should be, any of them should be true. That is, you can have multiple, like this you can have 10 up to 10, I mean you can have any number. And actually, okay, so the next the control flow is coming. Control flow actually, we have earlier discussed x less than y. So if x is less than y, then it should print what? X is less than y. And if x is greater than y is greater than x, it should print else. I mean, it's else. I mean, if x is less than y, then print x is less than y. If it is not true, then it should come and print the else statement, else if condition, x greater, y greater than x. Is that true? It is also true, but actually it will not be printed, because either x less than y will be printed, or else if will be printed, or else will be printed. Either one of them will be printed. Okay, so that is the case. So when you are looking x less than y, or x greater than y, or y greater than x, by default else will be the default one. If any none of them is true, then else will be printed when else block will be executed. As I told you, it has two things to remember. If statement will be having a condition as well as open brace, close brace. Similarly, you can, as earlier I told you, you can use AND or etc. inside this and combine multiple. This is the ternary operator. Ternary operator is actually almost like a x less than y and assignment. It's an assignment operator, ternary operator. Here we are given y is greater. It is checking y is greater than, and x is greater than y. It is false, right? X, because we have assigned the value x equal to 10 and y equal to 20. So this means that if x is less than, if x is greater than y, then we should assign x to x. That means it is almost same, right? That we didn't change anything. If x is greater than y, then we should assign x to x and y to y. It is almost same. It is, I mean, yeah. If you want, you can even change it to, if x is greater than y, is it true? No. So what will be printed? What will be the result? Y will be the true. If that is, because that is not the case, what actually happens is x equal to x will be assigned the value of y. Now what will be in the inside y, x is actually 20. Switch statement is similar. Inside the switch statement, this is the syntax of switch statement. I have given x divided by, because we are already having x equal to 20 there, x divided by 10, that is 2. Okay, so here what happens is we are having cases. Case statement is always having values, and a break statement, break at the end of that particular block. If you don't give the break, what happens is it will actually execute everything in sequence. After that, whatever is the true, after that everything will be executed. That's the thing. So you can see here, inside this 2 will be printed, and we have a default at the end. See, default, if none of them is true. Is it possible none of them is true? No, because we are given 20 divided by 10, then that will give you 2. But here we have any number, because 0 to 9 we have given, and one of them will be true. But here the default will not be executed at any case in this case. But in reality, what happens is either 0 will be given in the default or something like that. Okay. Okay. While loops. Okay. Any loop will be having a variable that will be initialized, and we check if that is variable reaches a particular value 10. Here we are actually 10. We are starting from 0 and we are incrementing I plus plus. So it will be incrementing from I equal to 0. Then it compares 0 is less than 10. Yes, true. Then it will be printing it like that. I becomes 1. Then it will be going and print checking if I equal to 2, I equal to 1, and then it is also less than 10. Then it prints like that. The next one, it is printed. It checked 3 is less than 10, and then it is incrementing. Then it is printing up to when it reaches the value 10. It is not becoming less than 10. I less than 10 is not happening, so it exits. Do while also is similar to earlier on, but do while will guarantee one time execution. That is, even if you give a 100 for value here, inside this value, even if we give 100, see, then also one time it will be executed. After execution, it will be checking whether it is less than 10. That is happening. Okay, so that is only the difference. So do while loop will having this syntax. Do will be started with a block, and while will be the condition given in the end, and it ends with a semicolon. This is the syntax. Do while is in the end block end. Similarly, so it is same as above. It every time what happens is it goes and actually check it, and then it increments. Every time it does that 1 0 1 2 3 up to 9. Then it actually 9 10. When it reaches 10, it exits. 9 is less than 10, and when it reaches 10, what happens is 10 is less than 10, then it exits. That's happening. Okay. Here 10 will be printed. Here only 9 will be printed. That's the difference. Now here also, because yeah. Here what happens is it prints up to 9 only. 0 to 9 it will be printing, the 10 will not be printed. This is there is two types of for loops. One is for I equals 0, that is any variable equal to 0, the initialized, here it is initializing. This is the initializing, this is condition statement. Okay, the next one is condition statement, this one, then the increment, this one is the increment. This is what happens. The next one is for arrays and other things. Okay, every time for generic arrays, not every array, generic arrays for integer, because we have created an integer array there, and for iterating or looping through the array we can use this. Like here, this is the array, this is the array value. For each value, this particular loop is executed. You don't have to do anything else in this case. When we seen an array earlier, it is the array actually you create like this. This is actually a static final array. We actually created it with a few data there, 1 to 5. Okay, here what happens is we create a new array and then we add values. Here also we add values. Create a double array, and we create, earlier double is actually 10.1 or 10.2 or 100.50 or 10.1 or something like that. So we this arrays.fill, arrays is actually a utility class, actually has a lot of helper functions there. You should go through that. A lot of things are there. As list, arrays.aslist, arrays.fill, a lot of things are there. Sort also there. A lot of things you can use it, because we can't actually complete everything in one single go. I'm not going through that in detail here. A dot length is important, because a dot length is the length of array. Here it will give the length of array as 10. 0 to 9 will be the index. Every time array will be having array will be starting the index at 0 and ending at n minus 1, and length will be always given as 10 only, because 0 to 9 is length 10. That is the thing. Here every time it is printing like this. Okay, every time it prints the integer array like this, then it will be printing the, what is that, it will be printing the double array. Okay, here again we are sorting. As I told you, it is having sort functions also. So here we are giving 52, 20. So the first one is index 0, that is 50 will be having index 0, and 20 will be having index, what is that, 7, I think. Yeah, index 7. Length will be a dot length. This also is possible. We are given like this. Please go through this, because syntaxes are very important, and it will actually print everything. Sort and printing, that means the smallest value is 20. 2 20s are there. After that 30 is there, 40, 10, 20, 2 20s, like that. The smallest value is 10. So when sorted, it becomes smallest value in the front, first thing. So when we print it, the smallest value comes in the front. binary search is there. So arrays dot binary search is there. From index 0 to b dot length, we will be printing. We are searching the value of 70. We can give any value there. Suppose we want to give 40, we can give that because it's available there. Okay. Then we actually go through the methods, functions. The methods are something just like data members. Earlier we had seen data members. Data members are the data of the class. The class actually any class or object provides data hiding. It's a security feature of class. Based on if it is a private data, it will not be available at any other class. So only any other objects, only in the super object it will be available. If it is ignoring like that. Yeah. Then actually actually we are having is a syntax of method. If you see here, the first is accessor, where all we can access this particular method of this class or object, and second one is what you are returning. So here we are not returning anything, so it is void. If you are not returning, please give void. The next is the method name, print. So if you watch closely, all methods are starting with small letters and all classes starts with capital letters. Here you can see this class starts with capital letters. Okay, this is actually we call this as a camel case. Okay, here we are assigning, here we are giving a parameter, we are passing a parameter v, okay, into this. Just like this, you can give any number of parameters. If you are having a string array or something like that, you can give string array or like that. Or you want to give, you can give anything there. You can give a class there. You can give a class. You can pass an object. No issues. Again, protected is there. Here you can see this is the accessor method for this particular method. Okay, accessor for this particular method. Again, this is also not returning anything. Going down, we see a private method. A private method cannot be accessed from outside the object. So this we are calling this get value. When we are actually getting the value, it is actually returning m that is assigned into this b is actually assigned to m. M is actually a data member of this particular class. So this is stored there. And actually we are returning this particular get value, means it is returning m. So here it will be printing the value. So even though we are given that in a different way, you can directly give m. Here you will be thinking, but this is a guide, right? I mean, so that we should understand things. So that's why I have given like this. You can directly give v or m here. We no issues. Okay. This are actually printing the values. Going backward now, actually I given a static, I given a static method here. It is called print me. It actually accepts a parameter or a method parameter string s. Okay, so all static methods are actually part of the class, not of the object. So it is only if you want to invoke a static method, you have to use class name dot method name. Okay, here we are passing this, so we'll be using like that. So here all the other methods, if you look here, all the other methods we are using, we have created an object, m, and then we are using it. See, m dot print, m dot get value 100. So that's what happening. Get value 100. It is getting the value here from here. Then it is coming back. This is the get value that is getting called. This get value called here. It is returning the m value and actually is printing. So here also, if you see, this is the way we are calling the static method. Okay, static methods are always called using the class name. It is not part of the object. Next is the actually oops concepts. Oops concept is set in another class. Okay, so inside Java is a single inheritance. So it actually imposes certain restrictions inside that. First is the single inheritance. That means you can have only one single parent, but it can have multiple interfaces. I mean, it can implement multiple interface. Okay. So here, first thing we given here is an interface. How to define an interface? Anything that you give inside an interface is actually final. If you give a data number there, it should be final. You can't change it. Okay, you can give data numbers there, but you can't change anything. That's the final thing. Again, public void print. Okay, print b is actually a method inside the interface. So if you are implementing it, you have to override and implement all that. I mean, give the details what the print b should be doing. Here, next we are going to the class vehicle. We have created a class vehicle, and inside the class vehicle we are implementing the print driver. This is a print driver. Okay, so we are having inside this class we are having a private data number. As I told you earlier, we can have private data numbers, public data numbers, protected data numbers, default data numbers. Okay, so inside this is a constructor. Every class has a constructor. That is actually this constructor actually does the initialization part of the once we are creating the object. It does the initialization part, assigning the values to the data numbers like that. It does. And here print we are actually, this is actually, you can give that at override. This is from the interface, right? You can organize. Again, we are having another method called printSum. This is for that's different. I mean, you can have multiple methods of the same name. You can actually return anything. Sometimes it can be void, or it can return an integer or a class or something. Anything it can be returning. Even a collection class, a collection object can return. So we can have any number of arguments. Whenever we are actually having same name, same method name, and a different number of arguments, we call it as method overloading. Okay. When actually we override or implement something, it is called method overriding. We can going down, you will be seeing that more. Okay, again we are having a class called car. It extends vehicle, earlier created vehicle. Car also is a string. Okay, so what actually super does, this is actually, we told you, the constructors initializes the objects. So here what super does is this, but we don't have a data member here. So this name is stored inside the super class. A print car is there. The print car is actually used to print the details of the car. Print sum is there. Print sum is actually overloading. Overriding the earlier one. Here this print sum actually overrides the earlier parent. And actually it prints car and the name of super dot name, because we don't have any as I told you, the data, a private data of the classes will be available only inside that class. So in order to access that, we call super dot name. That's it. See, it's private, and here we are using super dot name. Similarly, bus is there. Constructor bus initializes the object, and going down we have actually having print bus is there, and we have print sm is there. It is says it bus, it is a bus, a super data name. Actually this is an example only. So we are actually seeing another thing also here. It is print sm is actually we create a vehicle here, and we create one car and one bus. So everything is a vehicle. Okay, and we actually print sm or the vehicle will print a vehicle and whatever details they are given. This actually v is actually vehicle object, and so it will be printing only that. Going down we create car object, print v. Again, what is print v printing? Print v is actually printing the parent, yeah, parent name. So we are actually seeing some another aspect, that is we can actually assign, because car is a vehicle. Okay, car is a vehicle. We can assign car to vehicle directly without casting, because it is a vehicle is the parent of the car. Even we can print sm and all the details there. Print sm is actually the same. Okay, we are already, so there will be the parent value as well as the children value. Each time it gives a different what is that, it shows a different behavior. That is called polymorphism. Okay, however, when we override methods from the parent, it shows different methods at different time when calling the same method. Even though we are using the vehicle object only here. Okay, that's all about object oriented programming. There is another thing called inner classes. You can see inner classes everywhere. Here all we are created inner class only. These are all inner classes. See, all classes are inside some other class. So these are all inner classes, some other class or methods, and we are creating all objects inside that. These are all inner classes. That's it. Anonymous class also we will be seeing. Again, coming next, we are seeing here we are having exceptions. How to create a business exception. This is because exceptions are something, exceptions are to be handled when there is something happening in your application. You have to throw exception and let users, maybe users or administrators or whoever is managing the application, they should be knowing what is happening, right? Okay. So all the people, I mean, it may be even a clerk. If it is a bank, it can be a teller, it can be a clerk. So they should know what is happening inside. If there is something happening, you should not exceed some limits or something, then it should be happening. I mean, it should be giving information. So this exception is actually we can create an exception by extending exception. Okay, extending exception. Earlier I told you any exception constructor actually initializes that particular object. So it is just passing the object to the superclass message. So this is how we create the class. This is a very simple business exception we created. Again, in order to handle exception, there is two ways. One is using the try catch block, try catch finally block. If I am using something like this, throw a new exception. I mean, if I is less than 100, okay, we are passing I from somewhere. It may be 1 or 2 or 100 or something like that. If I less than 100, then throw business exception, I less than 100, and we print the value of I. This is the message that we pass to superclass. And when we print the stack trace here, we are actually printing the stack trace, right? So here we are actually having my business, we are catching my business exception here. See this, we are actually catching, we are trying something, we are catching business exception here, and we are printing the message. This is what we do inside okay, there is actually exception hierarchy is there. What is exception hierarchy? So we have actually we created business exception by extending exception, the normal exception. So if there is some other exception happening, this will be caught by the exception block. The first we give the child, then the parent, then it is if it is having any other parent, that parent class having any other parent, that also we can give. That's called exception hierarchy. And finally, if we want to give something else, we can also print that. Inside there is a block called finally. So normally we give a closing of something like streams or JDBC connections, closing of files or something like that, whichever requires a lot of CPU usage or something, we close immediately inside the finally block. That's happening. Okay, that's all about the, that is another way of handling exceptions. You can give throws. Okay, inside this one we can give throws. Okay, if we are not handling, if you don't want to handle it here and you want to handle it somewhere else, example, you are having an application server and you want to handle exception as at some interceptor or something. There is a exception handling interceptor, and actually you will be handling all these things inside that. So you will not be handling inside this, and you just throws exception, whatever exception it is, business exception or whatever it is. Just everything will be handled at a different class. In that case, here next coming the file handling is there. The file handle reading, we are actually, there is a lot of classes and other things are there. We are just now giving a very simple example of writing and reading strings. Okay, it is very simple. This is a reading file. That is, we don't have anything else. So first thing is we create a file object. You can see we create a file. All the data types. These are all classes and object name. Classes, object name. This buffered reader is there. File writer is there. And what we do is inside the try catch block, because it is actually file handling is IO exception is thrown. Okay, file not found exception is thrown. So that is that will be caught. That has to be processed also. So we create a new file with the path name, this thing given something like that. And next what we do is we will be using the buffered reader. What is buffered reader? Actually, buffered reader will be buffering all these things. It will not go and read every line. It reads everything into the buffer and then writes. So the IO actually decreases. All the reader actually reads a line. Okay, this FR is actually buffered reader. It reads a line, and when the EOF, that is end of file, is read, it will be throwing. It will be giving null value. We are actually checking it. So here what we try to do is we are trying to count the number of lines. So the number of finally we are printing the number of lines of the file. Like before, we are writing something. We are creating a new file. Okay, using the file writer, we are creating a new text file. You should know that file writers are but file writer actually writes only text. It is used for writing text file. So fw.write, we are creating fw, that is a file writer, and then we actually write the content of the file. Actually it throws IO section, as I told you earlier, and we are trying to catch it if there is any exception, and we will be printing it. using the stack trace. Here, if there is some other exception, that is, since it is a child class of exception class, we are actually using the exception hierarchy. We are using and printing it. Then actually finally we are actually closing everything. Take light frog, IO exception, whatever it is just printing it. This is actually a practical example of try catch, okay, or exception hierarchy and finally block. Again, this is another good example of multi-threading. Inside the multi-threading, we are having a class called sample thread, which implements runnable. There is actually multiple ways of using creating threads. This is one of them. Runnable interface is having one method, that is run. Okay, so this is the name of the thread we have given as by default we have given as sample thread. You can give any name there. Okay, sample thread name, like that we can give. And again we are actually giving sleeping milliseconds, catch interrupted. This one is again interrupted exception is thrown, so we are actually trying to hatch, and we have to try to catch it or we have to throw it. Both of them are accepted. Okay, this is how we create a thread when we are using runnable. If we are implementing runnable object, we create a thread like this. We actually create a new thread. This is a real thread object. Then we create the object that we created with the implementing runnable interface, and then we create then we actually call the start method of thread. Okay, we are passing the object with we have to actually pass with a object that have implemented runnable interface with the, so it is actually overriding at the run method, and using this we are actually starting it. When we call the start method, what happens, the thread is actually going and running the run method. This is it in the way of starting threads. You can see we have created a new thread by extending thread. This is extending thread. Okay, we create a thread by extending thread. Again, that is actually printing out all the values that is passed. So since this is actually you can see the constructor, sample thread one is a constructor with the parameter one, I, so it is passed like that. Every time we call here, because this one is actually a thread, it is having the start method, and we call the start method. This start method will call the run method every time. This is multi-threading. Again, the next multi-threading example is there using the executors. So this is actually fixed thread pool is there 5, and we create a runnable sample thread that we already created, right? And execute the worker. This worker is actually a thread. Runnable worker is a thread. Every time it will execute a thread, and or it will call the run method, and actually it get executed. So next time what happens is we call the shutdown. After everything, we call the shutdown, and we actually wait until every thread get completed, and you can actually give some messages here to see what is happening or something. Okay, it's up to you, and just do that. And finally we are creating the object and calling this particular method. this is yet another interesting uh, topic, that is a collection. We are actually not seeing everything inside the collection. We are just seeing list, set and map. This because it is more used than anything else, because we don't have to actually give array list string like that. I mean, we can directly assign as list, yes, no issues. Okay, so as we discussed earlier, this is another way of another for loop where it will iterate through the items. Okay, it will assign every item from top to first one to the last one, it will assign and we will print it. Actually there's a lot of methods inside list, set and map collection of all the collection classes. There's a lot of methods. Just go and see that, because collections itself would be actually normal in normal circumstances. It takes at least 4 to 5 days. I mean, that itself is a separate scenario. So we are going through this just to make you understand, to make you quickly start programming using Java. That's the aim of this. And also it gives you some mastery. If you don't know something, already you know. If you are, if you are you're starting up your programming career, this helps you a lot. And second thing, that is here what happens is list is actually all lists are ordered and set is unordered. That is the only difference, because two differences there. List is ordered, and actually we can have duplicate values. For example, I can have multiple hellos inside the list, but what happens inside set is that you cannot have something like that. You can have only unique values. 1 2 3 4 5, you give one more 5, then means the other 5 is deleted. So that's the difference. Okay, that is hash set. Hash set is actually an implementation of set that you already know. You can, because that is why it is getting assigned to a set, right? Okay, here the list is actually interface, set is interface. So these are the ways it is assigned. You can directly give arrays.asList, yes, no issues. Here you can give okay. Anyhow, let's continue with this, because he is printing everything. Again, another important thing is the hash map that you have come across. I have to put some values. You have maps are actually different from arrays or and sets. As I told you, set is having unique values and it's unordered, and here it is actually having two values, a key value and a key and a value pair. That's what key value pair is there. First is a integer, some ID is there. Second is a name. That is the case. And we actually use the put method and put everything there. And have a key. This everything will be. This is the initial capacity we given. Initial capacity actually determines how many. If you have any idea during startup how many elements you will be having, just keep that, because it will not go and increment the capacity of the size of the map every time. So this is very good. Initially keeping low will be nice if you are sure that it is low. So here we are actually having a map is having a key set method, and we can actually get a key set. So using the for loop, actually we iterate through the key set, and then we get map.get key of value. Okay, whenever we get key, it gives a value. That's it, and it prints. Again, maps, map, sets, list, everything is part of collection. Please remember. Next is another important and interesting. So far we haven't discussed anything like that because this is GUI. We can create applications in desktop using the Swing library. Creates application window with JF and capture the events. We use labels, text fields, buttons, and also JDialog. We have created one. We create a method for closing. That is, we create dispose. These are all, as I told you, these are all inner classes. Okay. So this is actually used to center a window. Any window you create can be centered using this particular method. What it does is, it actually gets, you can get toolkit dot get default toolkit dot print size and actually centers everything. That's what it does. This actually rectangle is having there's x comma y comma height width comma height. Okay. Next is the okay, this is actually a place where we create JLabel, JFrame. We are using JFrame, JLabel like that. JLabel is the part of Swing. Every component discussed is part of Swing only. JText field is there. Okay, we create a label name because once label will be used only for assigning. Adding to the panel or frame or whatever it is. Then from text field, it is actually we'll get the text values. Age field, you get the age values like that. We actually get, okay, this is not actually required. It will be there. Okay. Okay, button is there. Okay, we create a button, something for event capture only. So when button is actually clicked, it comes here. Inside this, this is actually called an anonymous class, an anonymous inner class. We didn't give any name for that. We just create a new class just like that. Action, whenever action is performed, it creates a new dialog box. It is model, layout is set, flow layout. Actually, this also you have to understand. There's different types of layouts like a border layout, flow layout, grid layout like that. You have to use whatever it is, whatever suits you for the particular purpose. And set bounds the center window. This actually set the size of the dialog box. So default close operation is actually dispose on close. We add some label and what is that, button also there. Again, coming here, you have another. This is actually this is a lambda expression. Inside this, you can see the same as this one, but this is a lambda expression. E actually having event is actually having a close window. Close window actually you've seen, which is actually disposing the whole thing. And JD dot dispose everything. JD is disposed. Close window is disposed. The JFrame is disposed. Everything is disposed. We are actually adding all things. JR, GR, everything set visibility true. This is actually event based. This actually happens when an event is happening. The button is clicked. Okay. And here we are actually adding everything to the panel. We are setting size and grid layout is added. Inside the grid layout, what we added, we create a layout. Panel layout is grid layout, and then we do the frame. Inside the frame we give the flow layout and the bounds. Bounds is set using the center window method for 400 size. A label, everything is added. You can see that all the components, label name, name field, label age, page field, just button, everything is added. We give a title to the frame and add the panel, okay, or add the panel here into the frame. Set visible true, default close operation for the is set, JFrame is set. So okay, this is what happens. So then we actually will be running this Java Swing example .st. Again, inside generic, there is another important concept called generic. So generic is something, there is type. We can actually give type in any type object. Example, in this what happens is it extends number and comparable. Any type that actually extends number and implements comparable, we can give here. That's the meaning. So this generic class, we just gave the name generic. You can give any name. It's not name dependent. You can give any name. Instead of generic, you can give any name. It's up to you. So this is important. What this means? This is allowing only specific type of specific types. That is, it should be number. Almost an integer, float, double, everything. It comes under this. It is implementing comparable, and it actually extends number only. You can use with all these things. Short is there, long is there, everything. Okay, everything comes under this. Inside this, this is actually a type. This is a type variable T. You can give anything. As I told you, all these are classes: integer, float, long, short, everything is classes. Byte. So here you can see the comparative method. This dot comparative is there. So going down, we are creating a object, that is gn1 is that. We create an object with integer. As I told you, integer is one of that. Then set value T. This value that we set is actually, since there is auto boxing, unboxing, this becomes an integer. Okay, integer value with T. There is 10. Integer class, integer, not int. And again, we are actually printing all these things. We are comparing gn1 dot compare to 10, like that. This is another wildcard. This is accepting anything. You can give any what is that? Any type here. We have two lists. We are trying to compare the size because now normally we don't know what is the size, but that we are giving. So list 1 and list 2 is there, and it can be anything. It may be string, or it can be integer, or it can be number, or anything. We are not limiting anything. Okay, list 1, list 2. Even though we gave two numbers, only we have to compare the size. Compare L1. That is generic wild. Generic wild is a class name, and we create compare LA1, LA2. This both are same. If you want, you can even add something like a string here. No issues. Okay, and then compare it. No issues. It's up to you. Okay, you can do that as a homework, or you can do it on your own. Next is actually lambda functions. So far we are aware that we can have classes. So this is another type of class. This is actually what is that? A final class. We can't actually change any value inside this. Okay. Once you create, no value is changed. That's record. Once create an object. Here we are actually creating and adding students, but we can't actually change anything. That's it. You can see this students. Student, this is student, this is student. Students is the array, is a list of all the students, and we are adding everything here. This is a base, and here what we try to do is we are trying to find out sum of ages. Is actually, you may be finding it stupid, but you can actually try to do that. We don't have any issues. Actually, what reduce does is there's two things. Yes, this actually this having a different syntax than the other things. Okay, what we do is we are actually converting the list to a stream. Inside the stream only we are using all the other things. Map yes such that s is age, s dot age, that is student dot age is s. Okay, then what we do is we will reduce this. The first value will be 0, and then what we do, identity is 0 and a comma b such that every time will be a plus b. Whenever two values are passed, it will be reducing all these values. This is the age sum. Okay, next is there is a different method of using finding the sum of age. I mean, sum of anything. It is just not just age or something. It can be anything. And here what we do, map to int, that we use, so that we can use this particular sum method here. That is the difference. Map to int is used as well as sum is used. So yes, s says that s is the age. Okay, and we actually this will be having the age sum is there, and we aggregate the age. That is what happens there. Again, next is the filtering. We just want to find all the students who has age less than 10, age greater than 10. No, age less than 10. Yeah, that's what is given, age less than 10. So we have to find the count, number of students who has age less than 10. That is 1, I think, because we don't have anything else. If it is less than equal to 10, it will be how much? It will be 3 or 4 will be there. This is syntax. You use filter. Earlier you used two different things, that is map and reduce, and also map to int and sum. Now we use filter. How filter is based on the age, we will be filtering it. Okay, age less than 10, we will count it, and the count is printed. Then is the collections dot sort. This is actually comparative. Normally in any collections dot sort there is a comparative. Okay, so this is the implementation for runtime implementation for. We actually don't do anything. We just give s1 comma s2 such that s1 dot age dot compare to s2 dot age. This is the only thing we give. I hope you understand. I mean, this is the syntax for that. Actually lot of different types of lambda is there. You can use a lot of different things for attaining the same, lot of different syntaxes to attain the same result. Here again for each is there, students dot for each. Every time a student is printed. I think there are also here only we are coming across that is age and yeah. So actually sorting the list and printing all the details. That is, or not all the details, name and age is printed. Okay, for each student. Just remember this. For each, we are not using anything, just on single line. Yes, such that print system dot out dot n and name is there. Again, filtering. Same earlier, what we did is we found the number of students with less than 10 age. Here what we do is we find we are actually filtering the whole list and creating a new stream. And this is actually a list of, a stream of all students with age less than equal to 10. Earlier age was less than 10, now it is less than equal to 10. As I told you earlier, there is only one student of age 9 and others are having 10 and 11. 10 is 3, so number of students will be 4. Filtered is the stream. From that stream, we will be printing each object there. Earlier we are using what is that, one lettered variables. Now we are using a student. That is the difference. You just remember, it is all the same only, nothing different. Again, sum of student age we are doing. No. Actually, this is something different. Number of vowels inside a string. We are finding the number of vowels inside a string. This is actually, there's a lot of expressions. You have to actually go through as per your requirement. You have to go through all these things. We have covered something like filter covered, map reduce covered, and what is that, int object to int, map to int dot sum covered. Then here what we are covering is map to object. Okay, dot sum. This is actually filtering everything and counting. This is what happens. So here we again, this match is actually regular expression. It actually checks if it is a part of a, I, or u. Actually, currently it is case sensitive, not insensitive. / I you have to give for making this case insensitive. So you are filtering and finding the count. That's what happens. So CND will be there, value, code points. This is the difference. Actually, here what you see is almost different from what you have seen earlier. Code points you have to give, and then you have to give map to object, because we are actually trying to count strings, that is all the particular characters inside the vowel characters inside the string. It's same as counting string. It's a string inside string or substring. Each of the character is a substring. That is the idea behind this. If any of that is A, I, O, U, any of that is I, O, U, then you have to take the count, the filter it. Okay, here this is the value. So as you can see, A of this sum is sum is having some one vowel U, O is having one vowel U, student is having two vowel U and E, and age is having two vowel A and E. The number of the count will be printed as 6. Okay, so now let us try to run the code and see what happens. Yeah, so this is actually the string that we are discussing earlier. You can give something like name, age. Let me hello constantly this out. Okay, so now let's actually see. We'll go through the results of what it is. Actually, we've gone through the data types and operators and expressions. Inside this assignment operator, different types of assignment operators are there. A plus equal 3, b minus minus equal minus minus 3, like that. Okay, everything. Again, we comparison operators, x less than, y less than, x equal to, y not equal to. Logical operators, x double equal to is equal to, okay, x double equal to and y double equal to, x equal to, or x equal to and y equal to means both of them should be true to enter the block, or means either at least one should be true to enter the block. Okay, control flow. Okay, this is actually ternary operator. Okay, question mark colon, 10 less than 10, switch statement. As I told you, inside the switch statement we gave what is 12 divided by 10, 20 divided by 10, that is 2. While loop. Okay, just while loop, we are printing while loop. Again we are printing do while loop, do while loop, for loop, for loop 2. That is this for the list arrays in Java. This actually automatically assigned values. Okay, fill values, sorting array, sorting values. 10, 20 sorted values are printed. Everything is sorted in ascending order. Binary search. Okay, here this is the binary search value. You can see the index is 4. Object oriented programming, vehicle is there. You can see vehicle is there, print vehicle is there, car Ferrari Sport is there, parent Ferrari Ford is there. These are all coming actually. Parent is coming from SM, I think. Yeah, so this is actually an example of, we are given examples of interfaces, classes, objects, data hiding, then constructors, methods, static methods, everything, and also polymorphism over data and function overloading, everything we covered. Methods in Java, because void method doesn't return anything. A void function can be called from any function can be called from anywhere, okay. That is actually, if a function can be called from anywhere, that means it is a public function. So we are passing string hello world, that's why it printed that static bar. So for any static method you have to use class name dot static method and pass the parameters to get the result. Exceptions, as we created a business exception and pass the value I is 10. Since I is less than 10, we will actually throw an exception. Okay, I is less than 100, we pass the we create the exception and throw that. That is what is printed as stack trace. New value of I, actually we after that in the finally block we incremented the value of I and printed it. File handling, number of lines inside the file that we read is actually 190, and inside multi-threading, okay, we create two threads first. thread 01, sample thread. Okay, up to this, actually it is normal multi-threading. From this onwards, we are actually creating using task, that is the executor. You can say 1, 2, 3, 4, 5, 6, 7, 8. Total number of threads is 10, 10, 9, 0 to 9. Okay, collections. We created from the array, we created this one. It says hello world. Okay. Then we are, this is actually a set. Okay. Then this is actually key value pairs, and we are printing it. This is again UI. You already seen that. We actually gave the name and age, and when we click that button, it actually gave a pop-up. When we it said hello name, and close button is there. When we click closed, actually it close all, that is the dialog box as well as the JFrame. Again, coming to the lambda operation that we just saw, it is giving sum of ages 50 for both. Okay, then there is one was actually using MapReduce and the other was using int dot sum. Okay, less than 10. Students with age less than 10 is 1, and sorted by age, it is actually sorting the list by age, 9, 10, 11. Okay, like that. And filtering, again this is filtering. It is done by age, less than equal to 10. Counting, that is the vowel counting. Number of vowels is 6. These are the things. So I hope you all enjoyed. If you have any, please go through, because of the time constraints, we included a lot of things inside this. Okay, so please continue watching. Please continue to share, subscribe, like, comment. I hope you all enjoyed. This will be very useful sessions for you. Thank you.